As with every living organism, proper health is the result of consistent testing. The variables between each test and the versatility of different tests combined paint a sound picture of the direction of change. Yet, with the vast amount of knowledge we have of our aquatic world, there is that much more that we still don't know. Here in Palmetto, the city took a giant leap in aquatic bioresearch, not only to restore the health of Palmetto Bay, but as a benchmark for undiscovered knowledge for other communities and cities. Since the installation of this project in early 2024, we have discovered a vast amount of technical data in this research. This research is the first of its kind. It has never been performed to this extent and testing due to the design layout of the reef pole grid pattern. The data collected was done quarterly throughout the year. The water monitoring involved testing of salinity, temperature, dissolved oxygen, nitrogen and phosphorus, bacteriological content, water clarity, which involves chlorophyll concentration, light penetration, and turbidity.
Yep, so basically we have our several sampling locations out there on the water. And so we're going to do two things. We collect field parameters. And so this is what you call a multimeter sonde or multimeter probe. It just collects a few things like water temperature, pH, dissolved oxygen, salinity, and conductivity. So you can see we have a few different probes on there. The different ones are dissolved oxygen, specific conductivity, temperature, water temperature, salinity, and pH. Turbidity meter. And this just collects, tells you the turbidity of the water. Turbidity is the reading of amount of like suspended particles up in the water. Just basically how far light can penetrate into the water. So if it's like really cloudy or if it's super clear, not color. So we just grab a little vial. This little thing will just shoot some beams of light into the vial and it'll tell you how turbid the water is. And then we also collect samples that go off to the lab. And so that's what these bottles are for here. So the few that we're doing, these are all pretty standard ones, so they'll go through lab analysis. So we have chlorophyll A, nutrients, which is total nitrogen and total phosphorus, enteric oxide, which is a bacteria that we sample for specifically in more marine water environments. Enteric oxide is a bacteria. It's found both naturally and in human and animal waste. So it's kind of an indicator bacteria. So if you sample for it in the water and you're getting high hits, it could be an indicator that there is other bacteria such as E. coli. We do quarterly sampling. This will be our second event and we're doing a total of 4. And our last one here is just total organic carbon, and that's just carbon's used by pretty much all life forms, so just kind of show. The last part we're doing, so those are all the water quality sampling. We're doing a little bit of wave monitoring. And so we're putting 2 of these in, one closer to the shore and another one a little bit further out, closer to the center of the channel. What these are basically are just pressure transducers, and pressure transducers are used in monitoring wells and all types of stuff, and it kind of just, it stays in the water, it tells you how much pressure is on top of it, and that gives you a depth reading. It kind of gives you a better reading on the wave energy that's going through. So essentially it's going to take continuous readings. We deploy them for 24 hours, and so you'll kind of get this output when it comes back. So we're going to strap this to one of the pylons out there for 24 hours, and then tomorrow we're going to come pick it back up, and it'll give you a 24-hour reading, and you'll see like on the graph how the tides and the waves have changed. And so we have 5 of them in the actual reef ball field itself, and then we have one out here underneath the railroad bridge just about.
Hi, my name is Ernesto Lazo de la Vega. This is the 3rd visit that we're going to be doing. We're going to be inspecting the reef balls. They're in clusters of 5 reef balls, different sizes, and they're all gathered from the river all the way to the mainland. So we'll have a whole series of reef balls, and we have selected 10% out of those reef balls to do an inspection. Now the inspection will be with a GoPro. We're gonna be looking down and looking inside the reef bowl and outside to see what kind of organisms are growing and colonizing these reef bowls. The organisms that we're looking for are oysters, but there are other filter feeders who are also has been colonizing. The sponges and tunicates, those two are filter feeders organisms, and they are attaching to the reef ball. So the whole community is getting enhanced by the water that is present in that system. Now, some places are going to be better suitable for them to colonize, others would not be so suitable. But this is all part of the lesson on this grid, because we'll understand the conditions, the physical and chemical conditions that suit them to colonize these reef balls. So there's stormwater water is coming from the north, from the mainland. The water is coming and rushing into it, carrying a lot of nutrients, fresh water. Those conditions will affect the biology on these reef balls. We've already seen some great approaches, because when we first put the reef balls, there was no growth whatsoever. But now we've seen inside the reef balls a bunch of little spats. Spats are the babies of the oysters, and they're growing and they're colonizing the inside layers of the reef balls. Outside, we have a lot of predators, other fish that comes and eat them. Now, this is part of the whole biology. The spats were now growing, and we're going to determine on this visit the size of the growth of the spats into a bigger size. And then we're going to evaluate what was the condition of detritus, which is unconsolidated flocculent material that is settling on top, and mud and algae, if there is algae growing on top of the reef balls. There are all these kind of characteristics, all these things that I just mentioned. They might impair the colonization of these attached organisms, like the filter feeders, sponges and tunicates, and even oysters. So we want to see the conditions from where that is prevalent and where there's none. And I can see right now that the closer to the river, the less detritus, filamentous algae, and these bad conditions are. And the closer to the mainland, yes, there is a lot of prevalence of these kind of conditions.
In short, we have seen a significant improvement in water quality in just the last quarter, as the oysters are increasing in numbers. Documented nitrogen levels dropped from 0.549 parts per million to 0.165 parts per million, and phosphorus levels from 0.24 parts per million to 0.15 parts per million. These numbers are the beginning of the process of cleaning the bay. We anticipate huge shifts as the oysters grow, and still more testing needs to be done. We must maximize this process to assess how we can improve it annually. We've already seen the results of Connor Park filtration into the bay, and now we're looking forward to a healthy aquatic environment in the years ahead.
Join us, Ernesto and his team, for video updates with test results of this project in the upcoming months. And as always, the Palmetto CRA would like to thank you for watching.